You know the scene, right? We've all seen it in the movies. A villain gets tossed into a volcano, there's a dramatic plunge, a slow, gurgling sink beneath the surface, and one last agonizing scream. It's pretty much the ultimate cinematic end. But is that what really happens? Let's peel back the Hollywood fiction and look at the hard scientific fact. So, does a human body actually sink into molten rock like it's some kind of fiery swimming pool? Do you just melt away over several terrible seconds? Well, the short answer is a hard no. Not even close. The reality is faster, it's stranger, and frankly, it's a lot more brutal than anything you've ever seen on a movie screen.
Okay, so let's just lay it all out here. On one side, you have the movie myth, that dramatic sinking, the long screams, the melting. And on the other side, the scientific reality. You'd actually float instantly. Your entire nervous system would shut down in less than half a second. And you wouldn't melt, you'd carbonize. The key takeaway here? Forget everything you think you know.
To really understand why all this happens, we first have to get our heads around what lava actually is, because it's not just some super hot liquid. Its physical properties are the absolute key to unlocking this whole mystery. For our hypothetical, and let's be honest, very unfortunate scenario, we're going to be dealing with a specific type of lava called pahoaho. This is that fluid, flowing kind you probably picture when you think of Hawaiian volcanoes. Yeah, think less like water and way more like incredibly hot, thick, gooey honey. And when I say incredibly hot, I really mean it. Pahoahe lava can get up to 1,200 degrees Celsius. Now, to put that into perspective for you, that is hotter than the surface of the planet Venus. This unbelievable heat is the very first reason why the movie version of events is completely impossible. And this right here is the first major myth we need to bust. You don't sink. You just don't. Lava, because it's molten rock, is incredibly dense. We're talking about 3 times denser than water, and way, way denser than the human body. So you wouldn't plunge into it. You would hit the surface and stay right there, floating on top. All right, now let's get to the core of it, the final moments. We're going to break down 1/10 of a second by 1/10 of a second what happens in that first and only second of contact. This isn't some slow burn. It's an instantaneous catastrophe. So check this out. Before you even touch it, while you're still in the air, the intense thermal radiation is already burning your skin. At 0.1 seconds, the very instant of contact, all the water in your body boils. And this isn't gradual. It's like a tiny explosion of steam inside your cells, causing immediate tissue death. By half a second, it's game over. Everything collapses. Your muscles, your tendons, and crucially, your nervous system shuts down like a blown fuse. You literally would not have time to even process pain. And by the 1-second mark, you're not melting. That intense heat triggers this ultra-accelerated decomposition, turning your body into carbon and releasing gases. So, this is the most important point. Forget the idea of melting like plastic. The correct word is carbonization. You essentially become a brittle, carbon-based form, kind of like a piece of charcoal in the blink of an eye. The organic material is just gone. Only the carbon is left. So what does that aftermath even look like? And does this purely hypothetical scenario have any connection to what we've seen from history's most infamous volcanic disasters? Well, the answer might surprise you, and it takes us back almost 2,000 years. This is the reality of it. Your final state is a carbonized form, just floating on the surface of the lava. There is no slow sinking, no big explosion, no thrashing around. It's just a quiet, instantaneous physical and chemical reaction. The theatrics, that's pure fiction. Now, you might be thinking this sounds impossibly fast, but this kind of rapid, heat-induced death actually has a really famous historical precedent, the eruption that destroyed Pompeii. But here's the twist. The real killing agent there wasn't actually lava. And this is where the comparison gets so fascinating. In our lava scenario, death is from direct contact with rock that's over 800 degrees Celsius. At Pompeii, the killer wasn't lava. It was something arguably even more terrifying, a pyroclastic flow. Just imagine a superheated hurricane of gas and ash, over 300 degrees, moving faster than a sports car. The key thing here isn't just the cause, but the effect. Even though it was technically cooler than lava, that intense heat was more than enough to essentially cook a person instantly, while the ash would cause asphyxiation in a single breath. It just goes to show you, whether it's direct contact with lava or being hit by a pyroclastic cloud, the end from extreme volcanic heat is brutally, scientifically, swift. So what's the real takeaway here? That dramatic, cinematic death in a volcano, it's all pure fiction. There are no final words,
There's no heroic struggle. In the end, it's not an epic battle against the elements, it's just a brief, brutal encounter with the laws of physics. And it's a stark reminder that reality is often far stranger and way more final than anything Hollywood could ever dream up.